Hello, everyone. My name is Praveen Narayan, and I'll be your host for today. Thank you for joining us for this webinar titled Data Warehouse and Data Lake Go Hybrid for Data Supremacy. The Economist in 2017 published a piece stating the most valuable resource is no longer oil, but data. 5 years down, Gartner expects 90% of corporate strategies to be deeply influenced by data analytics as an essential to drive ROI. This implies that companies will have to aim for contemporary and holistic data analytics strategies. However, issues like data accessibility and data quality sabotage their pursuit. In this webinar, we share insights on how you can reinvigorate your data analytics with hybrid data lakes, the pacemaker for data-driven businesses. Before we begin, a few housekeeping tips. We will take all the questions at the end of the webinar. If you have any questions, click on the question mark at the top right to submit your questions. In case we miss to answer your question during the stipulated time, we will write back. We will share the webinar recording with you within 3-5 working days. And before we jump into data lakes, a quick word on our speaker today. Our speaker for this webinar is Srinivasa Jallu, Director, Enterprise Data and Analytics at Compunal Digital. Srinivasa possesses about 2 decades of experience in software development, data warehouse, big data design, data analytics, data science, artificial intelligence, and machine learning. He has led data projects for many Fortune 500 companies. His expertise in the data space is second to none, and with his depth of experience working with offshore and remote teams, he is uniquely qualified to help organizations navigate the new normal. Over to you, Srinivas.
Thanks for introduction, Praveen. Hi all, good morning. This is Srini. So let's go to the actual agenda for today. So these are some of the topics and the points that I'm going to cover and discuss during our webinar today. So you might heard about the data lakes, data warehouses, and you might wonder what is the difference between them. Why we need the data lakes in real-time world. What are the current state of the data lakes that are initiated, are started, are completed by different organizations, what they're doing and how they're doing. And common data like design patterns also we see, and what are the challenges with it also we see, why Snowflake especially, and what it can do, and what it brings, the easiness and the sophisticated environment or the architecture or the platform to build their data lakes and the data warehouses. Okay, how can we enhance existing data lakes using Snowflake? For example, if you have any already existing data lake is there, now you want to move ahead towards Snowflake, how to enhance it or how to repurpose or reuse it. We'll see that. And then Snowflake as ETL engine, query engine for your existing data lake. And then I will show a small demo on the data lake and data warehouse on Snowflake. And then we'll go ahead towards question and answers. Okay, without wasting much time, let us go to the actual discussion. Okay, so this is data lake vs data warehouse. As I said earlier, a lot of people wonder what is this data lake and what is this data warehouse and how they're different each other. Okay, so which one should I choose for my organization? If I have both, how can I go ahead? If I already built the data warehouse, now it is my plan to go ahead with the data lake, is it okay? Or if I already had a data lake either on premise or else in different cloud platform, can I go ahead and build my data warehouse in Snowflake? At the same time, I can repurpose or use this data lake. So what is the main differences? And first of all, by looking at the different profiles as well as the different backgrounds of the mixed crowd of our audience, I made this webinar. It's like some places it is very business oriented, some places it is little technical, some places it is average, mixed both of technical and functional and business side. So I will try to make this webinar as lighter as possible to with the interest of reaching everybody, all the audience, all sort of audience within our webinar today. let us go and see what is the data warehouse. So this is not a new technology. Maybe from past 2 decades we have been playing and building a lot of data warehouses, that to traditional data warehouses, that to on premises in different platforms, right? So what is data warehouse? End of the day, it is a repository, so where different sets of the data, different kinds of data will come and together sit together in a single place, but in a highly modeled way. So highly modeled way means it's more structured, more defined, more cleaned. Okay, so data elements, objects in data warehouse, okay, will have a clear relation with other data within warehouse. That means every entity or the object within the data warehouse will have a clear relation with other objects within the data warehouse. And data available within data warehouse, I can say it's highly cleaned and standardized. So by this time you must understand, you already might have using in your organization as well. So traditional data lake, what is data lake means? So as the name suggests, right, the data lake is a central repository again, but where you can store all your structured, semi-structured, unstructured data at any scale for low cost. So this is the beauty of the data lakes. You can bring any sort of data, let it be a structured, a semi-structured, or unstructured, at any scale for the lower cost. We can store data in data lake as is. Okay, so without needing much structural changes, without doing much cleansing, we just bring the data as is format from our source systems, our online applications, whatever the application, source application that you are using in your organization. It's as is format, and as much as possible, all the data or majority of the data, either in structured, semi-structured, and unstructured, can be bring together here in this data lake. Now you can understand why data lake. I already have the data warehouse in my company. I am running my business intelligence applications over it. I am taking the reports and advantage of it. But then why data lake? So what is the specialty and what it brings for me on the table so that I can go ahead and implement it. So why data lake, right? So data lakes generally introduced maybe 10 years ago when the Hadoop systems, Hadoop ecosystem, Hadoop systems introduced to the market, and there was a big boom that time. So till that time, we were hearing about the data lakes, but the data lakes are here to address the many challenges that big data introduced. What are those challenges? Volume, velocity, and variety. So volume means organization want to store huge data at very low cost. So in terms of the data warehouse, if you want to bring all the data into the data warehouse, it is more structured. You need to put lot of investment to cleanse it and structured it and made it consumable format. And high volumes in the traditional data warehouse will not be support. After you reaching certain data, historical data of some size, it will give slowly performance issues and all. So volume is one concern for the companies, and variety. So as I said, variety. The traditional data warehouses will support only structural data. Okay, so it is relational and structural data, which has rows and columns. All the structures are predefined. It doesn't support unstructured and semi-structured data as well. It doesn't support. So that's where nowadays lot of companies are getting the data through the new channels. New channels here means we are getting the data from mobile applications or mobiles, social media, Twitter, whatnot. So IoT and your weblogs, lot of variety of the data they are accumulating, but their current existing data warehouses doesn't support their need. So that's where variety added to the data. So this kind of variety, different variety of the data will not be supported by data warehouse. So that's where the data lake is introduced. Okay, and then velocity. Of course, velocity also playing a major role. So nowadays nobody has that much time. Earlier days, what I used to see when I started my career 20 years ago, even we are okay to run the jobs weekly once or daily once. Okay, so there's no hurry because the kind of data that we are receiving that time, more traditional way and more relational way, more less, very less that time. So nowadays the data is huge, kind of data also generating in the market and organizations by the organizations issues, and they don't have that much time to see the data and realize and take the business decisions. They want to see the data just like near real time or near real time. What does it mean? For example, somebody tweeted right now about our product or the company, whether it's a good or bad. I want to see right now, right away. So I don't have a time to run my jobs in a batch mode after 24 hours. Okay, so I want to see next 5 minutes, next 1 minute, or right now. So the velocity also matters in that case. Again, here the data lake is introduced to solve this problem as well. So here, again, so why we need data lakes? With continuation to my talk, I will explain what it is. It's like iceberg. When you observe the icebergs, right? So only 22% will be on top of the water, and remaining everything under the water. So just like whatever in current scenario with the data warehouses and all, we are utilizing current utilized data for analytics is only 22%. So for example, your company is generating 100% of the data, out of which only 22% we are utilizing for the analytics purpose, but remaining 78% is unused or unutilized, I can say. So because we don't have the right platform to handle it, we don't have any data lake. So here the data lake will come to foreground and front ground, and it will solve this problem, and it can give the facility to unlock the remaining 78% missed opportunities also. Missed data means it's a missed opportunity for us. For example, let it be a clickstream data, log stream, social media, legacy data. So what sort of data we are getting in the form of unstructured and semi-structured, structured, let it be tweets or any kind of data. So that we are not able to process and take the decisions out of it because we don't have the right platform. So that's where the data lakes introduced and solve the problem. In the next slide, if you introduced the data lake into the organization, into your organization, or else into your data architecture layer within the data platforms or your data practice, so remaining 78% of the data also can be utilized and unlocked for your future needs. How it can help you here, customer intelligence and 360-degree view of the customer, IoT analytics, and integrated analytics, all these things can be possible. And now with the data warehouse and data lake combination, you will get 100% of the data and insights for your future analysis and other purposes. And for example, current state of data lakes, so this is one more interesting point and curiosity for every one of us. Okay, boss, you are saying that data lakes are good, but what are the current state of the data lakes, success criteria or usefulness? So 80% of the big data projects, right? So 80% of the big data projects were failed just because of certain reasons at different levels. What are that reasons and all we will see. Okay, so 84% of the CEOs worry about the quality of the data within their organization because the data lakes doesn't care about the structure and validity of the data, clean data. It will simply pull the data and keep it over there. So without having a proper planning and proper strategy, simply they are pushing the data all over the organization into data lake. So CEOs having one more trouble with the data lake world. If it is created in a more traditional way, that is the quality of data. There's no guarantee, there's no quality, so bundles of the data is pushing to data lakes, but at the end of the day they are compromising on the quality area. So 72% of the companies admitted that they have not forged a data driven culture at all, so because they're playing with a smaller amount of the data and they are not at unlock lot volume of data. So even they are saying that they are not data driven companies anymore because they're not utilizing their data 100%. And 60 to 73%, right? So enterprise data goes unused for analytics. Whatever the reason I told in the previous slide, because 78% is data is unused. So because of that, they are not able to get the analytics out of the data. So let us see what else is there, so how the traditional common data lake design pattern is there. And so I will tell you before we jump into that slide why we need data lakes and all. Okay, so why can't we exist with whatever the traditional data warehouse? Okay, after having these many failures, why these failures I will explain later. But after seeing these many failures of the projects, so why we need this data lakes? Yes, again, some cases, right? So there are some mission critical applications are there. For example, it's a banking or it's a healthcare. So some threats will happen. Okay, some fraud will happen. To detect a fraud within a bank, whether it is a fraud or correct transaction, on and average, as for the surveys, it is taking 279 days if they don't have a right platform or right tools. So after 279 days, if they are realizing that okay, there is some fraud happened, some fraud transaction happened, some threat is there, some we had to face a regulatory complexities, so complications. So that kind of issues they're realizing after 279 days. By the time whatever the damage in the form of regulatory issues, in the form of fines and penalties supposed to face by the vendors or the customers or whoever the organizations or the general bodies who monitor this regulatory operations has to face this customer, so to avoid that and to overcome that kind of issues, data lake is required. And why these many failures are there, I will tell you in the next slide. So it is a typical data lake design pattern for any of the company or any of the organization, in a traditional way. What is mean by traditional way here? If you look at here, so they have lot many data sources here. Let it be a IoT data or a traditional data, any logs, their maybe internet related, social media, mobile application data, everything data, every data they are taking maybe through Kafka or some other applications using streams. They are keeping in some data lake, so in the form of files. Okay, in the form of files, they're keeping huge bundles of the data here. Later, this is in one zone, one place, and later they're using certain applications like Spark, Apache Spark, or some other tools to cleanse it a little bit to make it conform and cleaned. And they again that service or the platform is different, so to move the data from here to here and here to here as a separate siloed applications or the platforms will take a lot of efforts and efforts and time and cost is involved. But at the same time, there is no guarantee that the data is transforming and translated and loading within the time as we expected. There's no guarantee over there. And at the same time, after that, they have to repump back to their data warehouse and all. Because of these three kind of layers and three kind of platforms, let it be on premise, your data lake is there, maybe your cleansing engine is somewhere there as a SaaS model. Again, your data warehouse is there in on premise or somewhere. Because of these, silos applications or the platforms, lot of issues in terms of transforming the data, loading the data, meeting the SLAs, and there are some error prone code, so which will have lot of competencies for the competencies and skills for the people to fix them. And there is a lot of manageability cost and upcoming and upfront maintenance cost as well as upgradation cost. These many things are involved. Because of that reason, most of the data lakes are troublesome for the companies and organizations, so they are failing quickly. So let us see challenges with this kind of data lake. These are working with most of the time files, very complex to administer and govern. Governing the data within these kind of data lakes also huge challenge for the companies. They had to face lot many regulatory issues. And so raw data, integrate this raw data with model data, that is one more challenge because those are there in different platforms and applications. And here slow performance analyzing data. And because right, so these are more traditionally built, they don't have that kind of platforms or the tools which can fasterly pull the data and analyze the data. Very difficult to evolve also. For example, in future they want to introduce 2 more or 3 more source systems into the same data lake. So evolving application also very troublesome because it is designed more very traditional way and on premise, some pieces cloud, some pieces, and again some third party applications are some pieces like these are like a bits and pieces siloed applications, I can say. Because of that, it's very difficult to evolve. So let us see what is this logical data zones that every organization will have. If you look at any of the organization, their data architecture or data platforms, they will have all this kind of data. Maybe if you're in your organization also, you might have observed everything. The very left side, the data sources, right? So structured data, that is like your Oracle SQL Server database kind of applications, semi-structured JSON, maybe XML kind of structures, and web APIs, web data, log data, as well as IoT data, all social media data will be there. And then very right side, consumers will be there. Consumers are like data visualization reporting, data science guys, as well as ad hoc queries. The business and the functional management or the middle management want to run their queries in ad hoc basis, that is also there. Now, if you look at the data zones, raw data zone, confirmed data zone, and reference data zone, as well as model data zone, and there is a work area and staging area. So these are the different data zones will be there for any organization within their data architecture or the platform. In generally, raw data zone is like supporting data lakes kind of applications, right? Simply it will pull the data and keep it here as is in the raw format, and then it will transform to confirmed, and then referenced means it's like a master data kind of. Okay, so and then model data, it is fully structured, it's a data warehouse kind of. Let us see, if you look at this, there is one more confusion. Okay, we can see by looking at this slide. Okay, the left side is the data lake, I understood correctly. The right side is the data warehouse. That means the raw data and confirmed data can clubbed and can assume together within this data zone. Okay, are my data lakes, and then the right side is the data warehouse. Okay, fine. So, and the next thing is, so how to club together? So that is one more challenge. My raw data is there, confirmed data is there, reference model data is there. Now logically I segregated it, but how to combine it, right? So that is where most of the most of the data lakes, right, on premise or more traditionally built data lakes are failing, because these are all the siloed applications. They are maintaining raw data somewhere, confirmed data somewhere, reference data somewhere, and model data warehouses somewhere. Okay, so they're facing a lot many troubles. How to club this logical area with this logical area, how to integrate it, how to transfer the data, transform the data between these two, from the raw data area to model data, confirm to reference, like that. So that is where the beauty of the Snowflake. So whatever the problems that I mentioned, whatever the reasons that I mentioned, that why the most of the data lakes are failing in real time, so all the problems are solved by one single platform, Snowflake. So if you observe carefully here, everything, raw data and confirmed data and reference data as well as model data. So all the four parts of this data zones are sitting and available within the single platform called Snowflake. What does it mean? The Snowflake will support the raw data forms and confirmed and then reference and model. That means it can take the data into their data lakes as is format. For example, you have a JSON file, it can pull it. If you have any XML, paraquet, any kind of files, so text files, it will take it as is format, and at the same time it can consume structured data as is format, web APIs, IoT data, everything in the raw format. And from there are some tools and techniques available within the Snowflake itself to extract the data as well as transform into confirmed, and then further transformed and cleans into reference and then model. Every operation to manage all these four data zones within the single platform called Snowflake, it has all the features available. In the upcoming slides, we will see how we can handle and what does it mean and all. And then, so let us see next one. So if it is little detailed manner I mentioned here. So what is Snowflake as a data lake? First, what is Snowflake as a data lake? First, we will see. So as I mentioned, IoT data and weblog data, all the mobile applications data, let it say any ERP data, CRM data, So all sort of data can be pulled into this Snowflake using different applications. Like they have some ETL partners, they have some internal ETL tools also, like Snowpipe, SnowSQL kind of mechanism. At the same time, they have lot many ETL partners also outside, like Informatica and Talent, Fivetran, Stitch. These kind of beautiful tools are there. They're really wonderful tool to extract the data from any form of this data to store into Snowflake easily without missing any records or the data, and without corrupting its format also. At the same time, batch mode also it can allow, maybe Kafka connectors also it will allow, because of the Kafka connectors, right? So the stream data analytics is possible. So the stream data is going to push it through the Kafka connector into a Snowflake, and it doesn't have any kind of restrictions or the limitation. You can take any kind of data into raw zone. Further, it will transform into the confirm zone and model zone, right? So once you pulled the data into this data lake, okay, and data lake, there are some tools. For example, you can play with the Python. You can write Python code to translate and transform the data, Spark ML and Jupyter. And there are Python Spark connectors also available to play the data and cleanse the data and transform the data from the Snowflake to different forms. And later it can be given to either data warehouses, or you have any third-party data lakes. You can push the data over there after cleansing and modeled. So this is the beauty of the Snowflake. It has all the features which can extract the data, that means any kind of data, and keep it here and play with it by using the different third-party tools or in-house tools also. So once the model data is ready, or the confirmed data is ready, you can, if you want to give the data in the format paraquet files. Okay, so you can give the paraquet files for further consumption of the maybe downstream applications. That is also possible. So let us zoom in to see more details, like what's happening. As I said, left side, all the data sources are fine. First it will ingest into raw data, and then ingest into in the form of logs and application logs. And then there is one beautiful feature within the Snowflake called variant data type. It can store any kind of data, that means like any semi-structured data, for that matter JSON or any semi-structured data. It can go and sit together within this data type. And then using some stream and task. It is a little technical I'm talking about, okay, so but I cannot escape it, make it understand. So there is stream and tasks are there, some tools and techniques internally. It will transform it to further and make the confirmed data. From there it will be cleaned and ready to consume its enriched data. From the raw format, we cleaned it and enriched through streams and tasks and some other techniques within the Snowflake. And from there we are going to push it to the underlying tables and model tables and views, and even materialized views to improve the performance. From there we can give this data to any of the BI tools, like either Looker, Power BI, or else Tableau, so any of the business intelligence tools. And the data analysts and business intelligence team and the top management executive team, CIOs, or for that matter any CX kind of profiles. And so data scientists will consume the data. They will ready with their analysis and metrics ready. And after that, if you see that, you might have a question here. What if I already have a data lake, okay, but you are saying that Snowflake is very good, okay, so how can I repurpose it? Should I scrap entirely my data lake, or what it is? How can I reuse or repurpose or enhance my existing data lake, either it is in a on-premise or else any third-party cloud platform, like maybe Azure or AWS or any kind of cloud platforms. If you already have a data lake, no need to redesign or re-architect the data lake again with respect to utilize Snowflake features. Snowflake complements your data lake, okay, so by fitting existing architecture. So how it is complement, how can it is like enhance your data lakes? Let us see in the later slides. But so definitely Snowflake use enhances your existing data lake up to some extent, and up to full extent, I can say. And there are some methods offered by Snowflake here. What are the methods? There is a query engine and Snowflake ETL engine. So if you want to use Snowflake as a query engine, that is also possible. If you want use Snowflake as a ETL engine without disturbing your original data lake, that is also possible. What is query engine and ETL engine? I will show you within the next slides. So what I can say, in a nutshell, everything in a nutshell, I can say, if you have a data lake already built and available, nothing to worry as such. You can use that data lake, and you can use the Snowflake to enhance it without moving that data lake towards Snowflake. Okay, so without scrapping it, you can repurpose and reuse it, but with the help of Snowflake, you can enhance certain features. Snowflake enhances existing data lake. What does it mean? I mentioned that we can use that one as a ETL engine. At the same time, we can use that one as a query engine as well. So what does it mean by ETL engine and query engine? For example, your data lake is created and available in certain on-premise or else any third-party tool. So you want to continue and use the same data lake, but you don't want to close it or scrap it. In that case, Snowflake will offer certain functions and facilities, the tools to extract the data. And so what does it do? It will take the raw data. It will apply certain aggregations or maybe cleansing operations, and it will transform to the conformed data. Again, it will give it to you to consume further in your data lake. That is one offer. It's a beautiful feature within Snowflake. We can use it to enhance your existing Snowflake data lake, existing on-premise data lake, or else any of the data lakes that you have already built in your organization. At the same time, you don't want to even pull the data and push the data and clean the data. So you want to enhance such a way that your query performance should be more enhanced, and you want to analyze the data in a speedy manner. That means as of now, your queries are some X, right? So maybe you want to improve your query performance or the analytical performance by 10x or 20x. Then you can use the Snowflake as a query engine as well. Within the ETL engine or else a query engine, there are tools and techniques which can support and help you. Let us see that in further slides. But what I can say, if you have a Snowflake if you have a data lake already built in your on-premise system or Hadoop system, for that matter, or any other application, you can use this Snowflake as a complementary tool or else a complementary product. So Snowflake enhances your existing data lake up to larger extent. Okay, so then let us move to, Snowflake is ETL engine for data lake. What does it mean? So it is little technical, but I have to explain it to make it clear for many of the audience who join now. So for example, your data is there. Already your data lake is built either on AWS based S3 buckets or else GCS or Azure storage. Okay, your files and all the raw format data is sitting over here. Now you don't want to scrap the data lake already built, but you want to extend and take the help from the Snowflake to enhance further. So how to do that? You can use Snowflake as a ETL engine in this case. So what does it mean by Snowflake as a ETL engine here? Simply you can push that files, so push that files. Maybe these are the raw data files, if you can see, and the raw data files you can push into Snowflake, and Snowflake will treat itself as a ETL engine. It will take the data, right? So whenever the notification that reaches to the Snowflake using some internal mechanisms, right, as in external tables concept, and it will streams and tasks, right? It will continuously move the data and transform the data and enrich the data. Finally, what does it do, right? So for example, if you want to store this data within the tables, from there you want to run some queries or maybe analytical operations, you can do that. But if you want to use Snowflake as just as an ETL engine, that is also possible here. So in that case, what you're going to do, all the raw data files without proper cleansing, without proper cleansing or scrubbing or any kind of operations, these are all the raw format data. If you give to Snowflake through ETL engine, Snowflake act as a ETL engine, it will cleanse it, it will enrich the data, and finally as a paraquet files or some kind of formatted files, you can take the data to feed into your own data lake. That means what? Here S3 bucket or GCS or maybe Google Cloud or else Azure storage, blob storage or any storage, you have all the file systems, right? All the files sitting over there. But up to now you don't know how to cleanse it and how to make them more usable and readable or consumable format. In that case, you can use the Snowflake as a ETL engine, and then if you give the raw formatted data to Snowflake, and it will transform and it will enrich up to a larger extent, and then it is going to give you a fully transformed and clean data like this. So that's what the beauty of Snowflake being a ETL engine for you. And from here, that is up to you. So now the data is enriched and cleansed and given to you, and now you can go back and feed this data into your original data lakes here. From there, maybe lot many downstream applications, lot many data analytics and data science applications which want to consume, so this data, BI application which want to consume this data, they can straight away can consume the data from there, and they can use the data for multi-purpose, let it be operational or strategical, tactical, for any kind of analytical operations. They can use that one. They can run some MLs on top of it. Okay, so machine learning programs or the algorithms, and there is no limit over there, because it is already transformed and it confirmed from the raw data to confirmed data, it translated and given back to you. So that's what the beauty of the Snowflake is, being an ETL engine. Now let us see how it is going to work as a reporting engine, query engine, right? So Snowflake is a query engine for data lake. So what does it mean here? For example, even you don't want to clean it again. Okay, so you want to use this time Snowflake as a query engine, but within the existing limitations at your side within your data lakes, you are not able to analyze the data in a faster pace or a speedy pace, right? So in that case, you can use the Snowflake as a query engine. That means it will take the data into its external tables, and it will read the metadata, and it will segregate into external tables, and then you can create a materialized view out of it, and even you can use the external tables as is. Okay, so you can run the SQL queries against it, and you can consume the data into your Tableau and Tableau or the Looker, or else maybe for that matter Power BI or any of the BI tools. So this is one method. If you don't want to use altogether as an ETL engine, the Snowflake, you can utilize Snowflake as your query engine, so that it beautifully works for you without having a lot of trouble, and without scrapping down or ramping down your original data lake that you already built all these years and already put a lot of investment on it. So that is the beauty of the Snowflake, can help you to enrich your existing data lake up to larger extent. So now let us move to the demo. So I have created certain tables and some semi-structured data within my Snowflake environment. I will show you that, and then we will move towards the question and answers after this demo. So let me open my applications. So if you look at my screen, right, so this is my Snowflake environment. Snowflake is a SaaS based product site. From the browser you can connect it and you can play with it. You can create any of the databases, data warehouses, data lakes, no limit for that matter. So what I did for our demo purpose, I created some small data lake, so demo data lake. Whatever the tables or the objects you can see here, I pulled it from the ERP systems or else the CRM system, from the source systems, right, as is same format. For example, if you see, if you're, I will run the query and show you. Okay, these are all your contacts data, but it is like, you know, the structured data, but you know, it's raw data for me. You know, it is not the data warehousing kind of model. So for that matter, you know, so you, if you want to see the data in other tables also, we can see, for example, for that matter, countries, right? So let me show you the data, what it is there. Okay, so you can see this data. So all these tables are the structured data. And now one more important thing I want to show, but you know, so hope you understood what I did here. I just created a data lake on top of my Snowflake application, and then, you know, so these are all the different other databases I created. But for our demo purpose, I created one special demo underscore data lake schema, I can call, within the same database or the database. Okay, so here I created and I pumped the data into multiple tables over here. You can see contacts, countries, customer, and employees, inventories, like that. And now I'm going to show you, for example, in case of contacts, it's a relational table, right? So you can see all the columns and all. It is columns and then relational table and having proper structure and all. In case of countries also, the same thing. It has a proper structure. Now I'm going to show you one more important table, right? So these are all the structural table. Now I'm going to show you sales analysis table. I created this table for a semi-structured data to capture. So what does it mean, semi-structured data? So if you look at, right, so in this one, you can see the data, but this is semi-structured. It's a JSON format. I can copy the data for you for better understanding. I'm going to keep you in a notepad, you know, so that you can see that, you can understand it. This is not the normal data for that matter. This is a semi-structured data. It has some customer details and their addresses, right? Addresses and you know, vehicle information. Some of the information it holds, but I was able to easily load this data also into the Snowflake without any hurdles. Very easy steps. And just for the sake of interest of the time and the saving of the time, I already created this table and made it available just for explaining purpose. But now if you want to see this data, okay boss, you are showing this table and which holds the semi-structured data, but I cannot see individually, I cannot understand this. So how to get the data? For example, I want to see what are the dealerships available in this table, right? So I'm running this query. Okay, so these are the two dealerships available in this table in the sales analysis. Now I'm going to show you salesperson information. I'm going to run this query. It is salesperson information, but you know, again, it is some branches are there. So how to avoid it? You know, so again, I can run this query, right? So this time we will see only the salesperson name. So what I'm doing all this, I ingested the semi-structured data within the Snowflake called sales analysis table. On that, this is the format that I'm using to run the queries, so that it is giving SRC colon dealership. That means it will go and fetch that data like that. In this case, what I did, SRC colon and then salesperson dot name. That means again, salesperson has multi-tree or the branches, you know, so branches within it. So what I did to segregate it further, I added dot name. So this time only salesperson name I will get here. So you can do anything, you know. In this case, I just loaded a JSON file. You can load any format semi-structured data file, just like this. And then further, you can go and see your data as well. With the interest of the time, I already made this data available for our understanding, and this is the small attempt I made to make you more clear what is data lake and how it look like, how it can store the data in the singular place, all the format of data, let it be structured. Okay, so all the other tables I have shown earlier, those are structured, and this is semi-structured data. Okay, it is a JSON format. Now let us go back to our original deck. So let me give me a minute. I'll put it in a presentation mode. Okay, so I hope you like this demo. Now I'm going towards the questions. In the beginning, whatever Praveen said, right? Let's follow the rules. and you can post your question. Praveen, what you?
Thank you, Srinivas. That was indeed a very informative and useful session. I would say a good load of information coming from you. And I'm hoping the audience uh, has got some very good takeaways. So, like Srinivas mentioned, we are open to questions now. Post your questions by clicking the question mark at the top right. We will write back to you if we miss answering any of your questions due to the lack of time. You can see there is a question already in the queue. If I could read it out, Srinivas, we built our data warehouse on Snowflake already. Can we build data lake now?
Exactly, it's a good question. So what I understood, right? So the customer is already having a data warehouse in their platform, maybe for example Snowflake. Okay, now they want to build the data lake, right? So absolutely it is possible. And what are the changes is going to happen in the future state? They are going to have the data lake right now, and they're going to build it, and latter point of time the data source for the data warehouse is going to be this data lake only. They need not to go and connect with the source applications directly like ERPs or CRMs, for that matter any of the source systems, source applications. Simply they can go and use and consume the data as a source, this data lake itself. For your question, yes, we can create the data lake also, even though the customer has data warehouse built already. Hope I answer your question.
Thank you, Srinivas. The next one in line, the next question, can we get a Snowflake free trial version to set up data warehouse and data lake on our own?
Yes, absolutely. I will show you how it look like. So if you go to the Snowflake web page, right? So here, if you see start for free option, if you click on that, there are a couple of options. You need not to go here, but so get started. I suggest once you start for free, right, you will get 400 credits worth of credits, right? So as a free of cost, and you can utilize, and then till it consumes. Okay, so you can select your platforms. Amazon, there are 3 cloud platforms. Snowflake is available, and regions also you can select, so that it will allow you to create your own environment like this. So you will see like this, you can play with it. Yeah, so yes, for your question, answer is yes, we can use the trial version also available for a month, or else 400 worth of credits, whichever comes first. Thank you.
The next one, Srinivas, is how can we ingest data into Snowflake data warehouse or data lake?
Yeah, so good question again. So there are some in-house tools also there available within Snowflake, okay, to ingest the data like Snowpipe or SnowSQL. Okay, at the same time, there is a lot of partner tools also there. Snowflake partners tools, those are the Snowflake partners. They're like ETL World, they are the legends, I can say, like Informatica or Talent. And there are some upcoming very interesting and capable enough tools like Stitch and Fivetran, and we have implemented this Fivetran for one of our client, and they are enjoying the results over there. And we have implemented Informatica intelligent cloud services. Okay, so and these kind of tools, third-party tools, through that we can ingest the data. And at the same time, if you want to make it more streamlined or streams, right, so click streams kind of data, that kind of data can be pushed to the Snowflake through Kafka connectors as well. So there is the different ways and different tools in-house as well as partner side. There are number of tools available, we can utilize it. Yeah, go ahead please. Thank you.
So this one's a long one. Let me know if I need to repeat it. The question goes, which option is better? Either to keep data lake outside and use Snowflake as ETL query engine, or build data lake within Snowflake itself?
I understand the question. Okay, so I always prefer to build the data lake within the Snowflake itself, where your data warehouse, our data lake, everything sit together, right? So side by side on the same platform, so that the cleansing and transforming the data, loading the data, transfer the data, transforming to different levels from the raw data to raw data into confirmed to reference to master data, or else, so I can say structured data, model data. All it is so flexible if you have your data warehouse, data lake in a single place. But there is no restrictions as such. For example, if your data lake is built already somewhere else, you can enhance that by using Snowflake as a complementary tool. So that is also possible. But my suggestion is, you can have, if you have your data warehouse, data lake, everything in a single platform called Snowflake, you will enjoy the more fruits and more benefits rather than you having it in a different platforms. But there is no restriction as such. You can have it either way. Hope I answered your question. Thank you.
Okay, the next one in line. What are the benefits of Snowflake data lake over on-premises Hadoop system data lake?
Got it. So the best benefits, right? The most of the failures are happening by using Hadoop ecosystem directly as is on-premise, because it requires lot of skill set, lot of expertise, and we have to monitor our own, and we have to maintain and set up all the Hadoop clusters, and to cleanse it, to get the data and load the data, and cleansing, lot of programs need to be rewrite, right, and the data pipelines also has to be written over there. There is like a lot of troublesome activities are there. If something fail, debugging issues and maintenance issues upcoming, and upfront upgradation issues, lot many issues are there in case of on-premise Hadoop based data lake. If it is in case of Snowflake, you just take the platform, whatever you want to create, you just create, and it's like a plug and play. All the maintenance, upgradation, auto up and down, and scale down, scale up, everything will be taken care by Snowflake itself. All of your admin activities, DBA activities will cut down by 99%, I can say, or even 100%. Okay, so that your team, rather than spending their time how to deal with the system and maintain and upgradation, all these activities, rather than that, they will focus on the data and understanding and analyzing the data. That's what. So that's what is the differences and the benefits of Snowflake data lake over on-premise Hadoop system. Hope I answer your question. Thank you.
I hope I'm sure that did answer the question. Like I mentioned, we are on top of the hour and through with the stipulated time. I would like to take this opportunity to thank each of you for being part of this webinar. We hope you have some valuable takeaways. Thank you, Srinivas, for sharing some very useful insights. Expect this webinar recording in your inbox within 3 to 5 working days. We encourage you to follow Compunal Digital's social media handles across LinkedIn, Twitter, and Facebook to stay attuned with our industry and technology focused webinar and content. Have a great day ahead. Thank you again, Srinivas.
Yes. Thank you, Praveen, and thank you, audience. Have a nice day. Thank you all. Bye-bye. Let's meet in the next webinar again. Thank you.